Hi, let's recall Le Chatelier's principle. Again, it says that when factors that influence an equilibrium are altered, the equilibrium will shift to a new position that tends to minimize those changes. And in the previous video, we talked about the effect of concentration. This time, we're going to talk about the effect of temperature to your equilibrium state. Now, basically, temperature is easy. All you need to do is think about two types of reactions: exothermic and endothermic reaction. Let's talk about an exothermic reaction. We said if it's exothermic reaction, heat is released in the product side. So when heat is released, heat is a product. Take note, it should be a product. So when heat is added to increase temperature, the reverse reaction will take place. So take note, if you add heat to an exothermic reaction, the reverse reaction will be favored because the reverse will become an endothermic process because it has to absorb the heat to compensate for the change in temperature. But if you remove heat to reduce temperature, a net forward reaction will occur so that the reduction of heat will produce the heat needed in the product. So remember, when you have an exothermic reaction and you see heat in the product side, exothermic reactions always favor the low temperature conditions. It doesn't need heat in the reactant side. So when you provide heat, that means you are favoring the reverse reaction. If you reduce heat, that means you are favoring the forward reaction. So that's it for exothermic. Add heat, reverse. If you reduce heat, it's the forward reaction. If you have an endothermic reaction, in this case, this sample equation here in which your change in enthalpy is positive, that means you need to supply heat. In this case, in endothermic reaction, the system will have to absorb heat and heat becomes your reactant and you find it on the left side of the equation. And so if you add heat to increase temperature, of course, it will cause the reaction to proceed moving to the right or to the forward reaction because you're adding heat. If you remove heat to reduce the temperature, it will cause the reverse reaction moving to the left because you need to compensate for the removal of the heat. So endothermic reactions therefore will favor high temperature condition. So you add heat, it will favor the forward. You remove heat, it's going to favor the reverse reaction. So that's it. That's how easy it is to predict the position of the equilibrium. How will it minimize the effect of adding or removing heat either to an endothermic or exothermic system? So this is it. This is Madam Narca saying don't stop learning, relearning, and unlearning till next series of my online lecture videos. God bless you. Bye-bye.